Hi Professor, I'm Krishna Nathan. I belong to Group 2. We've been assigned regression and classification widgets. I worked on regression tree widget and regression tree graph widget. Regression tree is a decision tree which is used to predict data using various regression models. The scores are calculated based on the prediction we make and is compared to the actual data which is available. And the errors are calculated. If the errors are low, which it means that our prediction is correct. For this particular assignment, I've been provided the data which deals with movie reviews. There is data from 4 different reviewers. Each reviewer has three files. One file deals with ID, which has the IDs of every author. The second deals with the rating, which every author has given to a particular movie. And the third, which is the subject, which deals with the actual review. It has the content of the actual review. Now for this particular widget, we need numerical data. So all the attributes that are involved should have numerical data. So we'll have to process our data such that we input only numerical data. So for that, I had to import data from the particular text file and set delimiter as tabbed and convert them into a particular column. This is how I did it. I go to a particular file. For example, I open rating. So here I've used tab as my delimiter, and then converted the particular text file into a column. So this rating has come from the rating text file. This reviewer column defines from which reviewer this rating belongs to. This verdict has been calculated using a formula. So we have predicted that anything less than 0.7 should be given 3. 3 means good, and anything less than or equal to 0.4 means 2, that is moderate. Anything below 4 should be 1, so that is bad. So based on this formula, we've computed and calculated the verdict column. And now we've compiled all the data from different reviewers, and this is the final input file. So this contains about 5006 elements. So this forms our input. For regression tree, we go to orange, and here I will open a save schema. I call the input file here. This is my input file, which contains 506 elements. So this gives me an output. So this shows that this gives the list of scores. These are errors that are being calculated. Now the comparison happens between the predicted value and the actual value. Here we see all are 0 because now we can infer that our prediction is correct. So just to confirm, I have a data which is incorrect. I've just modified the input file, just changed the rating. Here this is the actual data. This is a subset of the actual data. So it contains the actual rating. For 0.7 it is verdict is 1. So this I've modified and converted here. So for everything it is 0.3, just to see if the regression which it works properly, and see if we can populate any errors here. So this, I'm using this particular changed input as my data set. So I call this modified data set here. This is my modified data set. So when I try to check, see now we see a list of values here. So this shows that there are errors in the particular prediction we made for this particular input. But in case of our actual input, we don't see any error, so that means that our prediction is correct. So we can infer that the data which we have got and the prediction we made is correct. Now let's move to regression tree graph. Regression tree graph actually represents the same data in a graphical format. So here is my input file. I've called the input file. You can see the output. This is the total data. I mean, it is trying to represent all the data in a graphical structure. Now we'll have to set a stopping criteria. So this stopping criteria can be set in the regression tree widget. Here it says pre-puring. Here I can set to 500. So this when we set to 500, it says that it cannot split any child node which is less than 500, which consists of which contains any less than 500 elements. So here you see the output. See the output, it is a lot smaller. So now we have created a stopping criteria such that we don't split if the element is having anything less than 500 instance. Now when we check on this number of instance, we can see that if the instance is less than 500, we don't split it any further. So this is the final graph. Now this data which we actually got is represented into a graphical format. Here the input data, if you look at the input data, now the verdict becomes the class attribute. So we have used this as a class attribute, and this splitting is based on rating column. So here if you see the actual graph, now the condition is based on the rating. So anything less than or greater than that particular rating, the binary tree structure is generated. So if you see the errors here, we can see the second entry is actually the error. So we see that almost all the child nodes have error as 0, so we can infer that our prediction is correct. So for this particular data which we've been provided, we constructed a regression tree graph and a regression tree to see if our prediction is correct. Our prediction is correct since we don't generate any errors here in this graph. So this shows that the regression algorithm or the regression model which is being used is correct.